So there's just two last details that I want to cover from section 2.2, and they're both fairly quick. So the first one is how matrices behave with respect to calculus. And so if you have some matrix A and it's got functions of t in it, so maybe like t squared minus 3 and e to the 2t and sine of t, whatever. And so actually I guess I should say this is a as a function of t, and you want to differentiate it, so you want to talk about a prime. You just do everything component wise exactly the way that you think you might. So just like we do scalar multiplication entry wise and just do the scalar multiple of every single entry, it's exactly the same for differentiation or integration. You just differentiate each coordinate independently of all the others, and there's nothing more to it than that. The other thing that I wanted to mention is that it's important to think about multiplying a matrix by a column vector in certain different types of ways. So suppose our coefficient matrix A looks like we've got A11, A12, so on and so forth. Here I'll write in a couple of A12, out to A1. It's got to N. And then we have A21, A22, out to A2N, and AN1, AN2, ANN, like so. And if we multiply this by some vector, so x is some column vector like this, then let's see what happens when we multiply this row times this column. We get A11 x1 plus A12 x2 plus out to A1n xn. And then similarly, we're going to get A21 x1 plus A22 x2 plus A2n xn, all the way down to AN1, AN2, ANN. So we have this guy. And now what I can do is I can split this apart. So I notice, for example, that all of these terms have an x1, and all of these have an x2, and all of these have an xn. And so that means I can rewrite this as the column vector A11, A21, AN1, and everybody in this one has a common factor of x1, so I'll pull that out in front. And then for the next one I have A12, A22, down to AN2, and those guys all have a common factor of x2, and so on. Okay, so the key point is that if we look at these guys here, these are columns of A. So just come back, there's the first vector, there's the second vector, there's the last vector, etc., right? So what we need to keep in mind is that AX is a linear combination of columns of A, where the coefficients are given by the entries of X. And that way of thinking about a times x will be very useful in the days to come.